So, how are you, JNV? Haveri? You have logged into through your JNV school account, na? Okay. So, good evening to you. Uh, Let me wait for 1 or 2 minutes more. Let the others to be joined. Then we will start the lecture. Okay. Okay. Firstly, make sure the screen is visible to you and I'm audible to you. Is this so? Okay. Wait for 1 minute. Then we will start. So, how's your question solving part is going on? How's your AIT? As you attempt the AIT, it is for the 11th and 12th both, na? Or it just for 12th? Or whatever is that. So, are you trying to solve the question for like gravitation that we are dealing with? Okay, very good. In the previous lecture, like in every lecture, we will did recall. Okay, we recall some the previous concept. In recall part, if you find any trouble like that concept was not clear to me, you can raise your hand or ask in the chat box. Whatever source you can use, you can just let me know ki in this concept I am finding trouble. So I will re-explain it for you. Okay? Got it. So here we are with our lecture number 7 in gravitation. So in this series, we have completed 6 lectures. Till now, what we have covered the Newton laws of gravitation. Okay. Then the gravitational field, gravitational field intensity, gravity, which is the acceleration generated by the Earth, the gravitational acceleration. We have also seen the different kind of bodies, how they are generating this electric field intensity, what are the derivation of it. And we have also derived this for a ring and disk, uniform solid sphere, and hollow sphere. Hollow sphere we can also consider to be as a thin shell, okay? Thin spherical shell. So for all of that, we have derived the gravitational field intensity. In the case of ring, we have also find out that where the intensity will be maximum. Okay, it will be maximum at plus minus r by root 2. है ना? After that, in the previous session, in the previous lecture, we have derived the expression for gravity, the gravitational acceleration above the Earth's surface, below the Earth's surface, and how it is affecting our Earth. And our Earth is how affecting the gravitational acceleration value. So basically, there are two factors which can affect it, and let me see in the recall part. Okay. Because you guys have not attended the lecture so well in the previous one, you have leave the lecture so early. So there is a very important concept that I need to be discussed in that lecture. I have just leave it, or that concept, the concept of gravitational potential energy. That is the core of this chapter. Okay. I have discussed, not on that day. I'm discussing it for today. So please be with me for the entire lecture so that you can get the maximum of it. Okay? Just because of you guys, I have not did it in the previous class. Because what what is the outcome of that if I just did it and you are not there? And I want you to understand each and every concept of physics that I taught you. So aim for today is firstly we are going to recall. Then we will learn about the gravitational potential energy. From the concept of law of conservation of energy, we will derive the expression for orbital velocity, then the escape velocity, and then we will see the trajectory of uh, different velocities. Like a body is thrown from some height with different velocities, but these velocities are not too small. These velocities are comparable to the orbital velocity and escape velocity. So we will see what are types of trajectory they will have. Okay. Now, in the previous lecture, we will derive the expression for the gravitational field, gravitational acceleration. Okay. So effect of various factor we have seen on the gravitational acceleration. Mostly the shape of Earth and the rotation of Earth about its own axis play the maximum role, and they will affect the value of gravitational acceleration. How? So, because of the rotation of Earth, the part which is perpendicular to the axis, not in line in the axis, not along the axis. If this is the Earth, just a second. If this is our Earth and it is rotating about this axis, so the part I'm talking about, this part will feel a centrifugal force Fg outwards, and because of that, the mass and this part, you will see the upper part will have a centripetal force. So it try to pushes down. Okay, it try to pushes down, and because of the circular movement, the Fg force trying to get it out. So the shape of Earth finally will be flattened from the pole and it bulges out from the equator. So finally we will have a shape of Earth which is oval in shape. Okay. Because of this oval shape, you will find a difference of the radius from the pole to the center and from the equator to the center. So the difference, because equator has a large distance. So from the difference of equator, radius from the equator and radius from the pole is approximately 32 kilometer, which is a significant difference. No? Okay. And we know that the gravitational acceleration is nothing but at the surface it is gme over re square. But you can say that for our equator, it is greater than our pole. So if this is greater, the value of g will the value of j will decrease. So we can say that the gravitational value of acceleration, the gravitational acceleration at pole is greater than the gravitational acceleration on equator. Got it? Although because of the rotation of the earth, we have seen and also derived it. Okay? No one is going to tell you about the derivation of this, but we have derived it, and we will finally come across at this expression, which is g dash is equals to g minus re omega square cos square theta. Okay? So we can say that omega is the angular velocity of earth. At poles, this theta would become 90 degree. Theta is 90 at pole. You have considered a point here on earth. So if you rotate this vector, this line to the pole, the angle will become 90 degree, and this is the equator. So if you rotate this line to this line, the angle will become 0 degree. Okay. So at pole theta is equals to 90 degree. If you put this in this expression, so cos 90 will be 0. So this term, this re omega square cos square theta is a variable term, and it is varying according to cos square theta. And cos square theta has a minimum value of 0 at theta is equals to 90. So this whole term become negative, minimum value. And if you are subtracting something from a constant value to the minimum value, then g dash you will have the maximum value. So at pole, you can say we will have the maximum gravitational acceleration, g of pole. Okay. At equator, theta is equals to 0, so cos 0 is equals to 1. So g you have as z minimum. Okay. Also, one thing that I want to tell you, if the earth is rotating about the axis passing through the poles, okay, and if earth start rotating, then what will be the effect on the gravity? Okay, you will see that the g dash is equals to g dash will become g, because omega will become 0. Okay, so if earth stops rotating, the gravitational value will become the value of gravity at surface. Okay, but this value, this g, is also dependent on the whether you are measuring it from the pole or measuring it from the equator. Okay, so at equator you have the lesser gravitational acceleration than pole, and if you are sitting at the pole and earth just earth stop rotating, so if you are anywhere but not on the pole, you will if earth stop rotating for only 1 second, you will feel a very high deaccelerating force. Okay, and all the things will vanish, because if the earth rotate, you are also rotating with earth with 32 km/h. Okay, about its axis. Okay, got it. So at a very high speed, according to Newton first law, the thing will stay in rest, stay in rest, and the thing which is moving keep moving until and unless there is an external force came into contact. Okay. So there is no external force if the gravity suddenly stops. If the earth stop rotating, then what is the force? Who is going to stop us? We are also rotating with it. Okay. So earth has stopped by the influence of force, but we are not. So we will start moving at a very high speed. So you will stuck. If you are standing in front of a wall, you will go through that wall and destroy it. Although you are destroying yourself, but all the things will vanish. On the only way to escape from this situation without any harm, to locate yourself at the pole, because pole is the at pole we have center of rotation, axis of rotation, and if you are get yourself on the axis of rotation, the omega is 0 there. Okay, because v is equals to r omega, and r is 0, so omega will be 0. So the only way to hide, to escape from this situation, is just build a house on pole, and which is not possible for you. Okay, so you will have the consequences. Even I will have. Okay, so don't worry, it is not going to happen till now. You cannot say about the future. Now, the gravitational potential energy. You have also seen this term, the gravitational, the potential energy in work energy and power. Work energy and power may it has a detailed explanation at what a potential energy in and all. Okay. Now you can say that the potential energy is the capacity of any system. Potential means system. Sorry, potential means capacity. So this energy is somehow related to the capacity of the system. And also from the definition of potential energy from work energy and power, it is the energy acquired by an object or a system by its change in configuration. अगर सिस्टम अपनी पोजीशन को चेंज करता है, कॉन्फ़िगरेशन को चेंज करता है, it will acquire some kind of energy inside it, and that energy is termed as the potential energy. Okay. By changing the configuration, you are changing the potential inside it. Okay. That is why this energy is termed as potential energy, which comes by the change in configuration, change in situation, change in position of a system. Okay. Like this, my hand. This is my hand. It is resting on the another hand. If I take it up, now I have changed the configuration of my hand, the position of my hand. So it has acquired some kind of energy in it. If I drop, it will freely drop because of this potential energy. Okay. So the kinetic energy you will have it because of the change in motion, change in speed, and because of the speed. But the potential energy you will have only because of the configuration, the position. Okay. Got it. So from the definition, you will see that the gravitational potential energy, if I talk about, is the energy processed or acquired by an object due to the change in its position when it is present in a gravitational field. So वो change of configuration, change of position भी किस field में होना चाहिए? एक conservative field में होना चाहिए. We have learned about in the work energy and power. Okay. The force that causes that change, the field that causes that change will be conservative. That is how you are going to store some potential energy. Okay. In non-conservative field, there is no conservation of potential energy. Okay. There is no specific term for the potential field. Only the conservative force has this uh, special feature that it can create a field around it which is conservative in nature, and that is why it is developing a potential energy. Okay. For any object present in that field. Okay. You can see in this example for this cyclist. This cyclist initially at 0, when it reaches the topmost position, the energy acquired by it will be high because constantly it is changing its position from here to here, and it is changing the height. So if the potential energy at this point, at the reference point, E is equals to 0, you can consider this as a reference line. So at this height, it has acquired some of the potential energy, and that is to be used from this decline motion. For this motion, it has to put some effort to climb at that cliff. Okay? But from there, it will not have to do that. The cycle will freely fall because the work that this cyclist has did here, the work done is stored as the stored as potential energy, because this cyclist is in a field of conservative force. I have told you in the very first lecture or in the second lecture that the gravitational forces of attraction are conservative in nature, and that is why the field created by them, that is the gravitational field, is also conservative, and this cyclist is moving in this conservative field. So when changing its position from here to here, it will acquire some kind of potential energy. You can see in the graph, as is changing the position, the graph increases its value, increasing the value of potential energy, and as soon as it changes again the position, the potential energy will drop down. Similarly, you can see here in this example, this ball is moving from this point to this point. So at the highest point, it acquires the potential energy, and here this potential energy converts it into kinetic energy if there is no non-conservative forces are present. So that is why you can apply the conservation of mechanical energy only in the case of when conservative forces are there. Okay. So in simple term, you can say it can be said that gravitational potential energy is an energy that is related to the gravitational force or to the gravity. Okay. I hope this definition part is clear to you. Okay. If anyone has any kind of doubt, they can ask in the chat box or raise their hand. Okay. Now, once more, you can see that the cyclist is changing its position, acquiring some potential energy. Again, it is changing its position. It de-acquire the potential energy. It uses the potential energy. Okay. Now the derivation of gravitational potential energy. How the derivation will goes on. So we will consider a particle. Consider two particles, A and B. So suppose we have two particles. This is A and this is B. Okay. So from the work energy and power chapter, we know that the change in potential energy U final minus U initial is equals to the negative of F conservative dot dr, the work done by the conservative force. Okay. So that formula we are going to use here. Got it? So the change in potential energy, actually the change in potential energy is described, not the actual potential energy. Okay? Only the change of potential energy you can say. You cannot say about anything about the actual potential. For that, you have to consider a reference frame. Okay? So if we take this particle, because this particle A has mass m1 and this particle B has mass m2. So this particle m2 we are focusing on, it is in the field of gravitational field of m1. So this A, I can say this apply a force towards A, which is Fa. So what I am doing is I am shifting this mass m2 at a distance at a distance dr. This is dr, and initially they are having a distance of r. Okay? Got it? Initially they are separated by a distance r. Okay? And what I have did, we have shifted this position of this particle B to r plus dr. Now from A, this position, this particle is at r plus dr. Got it? So what kind of work we have to do in this case? है ना? Because this m2 is present in the field of m1. This m1 is applying a force in this direction. It's just trying to attract it. And in opposite to that, we have take it from this position from B to C. You can say this is point C. Okay. Now, so the force applied, which is Fa, is the conservative force, and force applied by A on B is G m1 m2 by r square. This is equation number 1. And if I consider it in vector form, so it is a negative also, because it is attractive type of force. So this, you can say, according to the axis, this is positive and this is negative, and it is acting towards the negative axis. Okay. Now, this is the only conservative force against which we have done some work by displacing this particle from B to C with a displacement of dr. So we have to do some work, and that work is done against the Fa, which is a conservative force. Okay. So you can say that this dw, work done, is equals to integration. You can say it is Fc dot dr. You can say that this is gm1 m2 divided by r square minus, because Fc is equals to Fa. It is the conservative force. You can, it is conservative, and that is exactly equals to Fa, which is minus gm1 m2 by r square dot dr. Okay. Now you can say that initially, if the particle is at r1 and we have taken it to the r2, okay, from position r1 we have taken it to the position r2. Got it? So limits are from r1 to r2. Now put this dw, because this is the same example, like potential energy final minus potential energy initial is equals to the negative of work done by conservative force, Fc dot dr. Put this value in the expression. So you will see that this u final minus u initial equals to minus, already present here, and this dw is nothing but F conservative dot dr, the value that we have derived earlier. So you will put that dw in this expression. So it is minus gm1 m2 by r square into dot dr. This minus multiply with this minus become plus. So plus integration of gm1 m2 by r square dr, and limits are from r1 to r2. So u final minus u initial. Now g m1 m2 are constant, so you can take it out from the integration. It is r1 r2 1 upon r square dr. Now integration of 1 upon x square dx will become minus 1 upon x. So this formula we are going to use here. Instead of x, we are going to put r. So u final minus u initial is equals to g m1 m2 into minus 1 upon r, and limits are from r1 to r2. So to remove this minus, you can just change the limit. It is now r1 to r2. You can change it for r2 to r1, and this minus will vanish out. Or you can simply open the expression of it. U initial g m1 m2 into minus 1 upon r2. I have not changed the limit. Minus, and minus is already present, so minus minus plus 1 upon r. So you can say that u final minus u initial, is g m1 m2 into 1 upon r1 minus 1 upon r2. Okay. So this is the final expression And this is the most general expression of potential energy that you will have. Okay. Now, if if R2, if you can say, if the particle initially they have separated at infinity, and you consider the initial kinetic energy, initial potential energy for infinity to be zero. So initially particle is at R1. So let's say R1 is equals to infinity. Put the R1 is equals to infinity. So Ui will become zero. This is the reference potential energy. So at infinity, the potential energy will become zero. So finally, you will have expression U finally you can consider to be U is equals to minus G M1 M2 by R. You can consider this R2 is equals to R2 is equals to R. Okay. So this is the final expression of gravitational potential energy that you will have in your hand, which is just the product of mass divided by the distance between them. Okay. So if you have any kind of doubt in this expression, you can just ask. Okay. Otherwise, we will move on to the next topic. Make sure you note it down. Each and every concept is clear to you from this point. Okay. So if there are, like say, if you have three particles in the system in the form of triangle, this is M1, this is M2, and this is M3. So what is the gravitational potential energy of this system? And this is R1, this is R2, and this is R3, the distance between them. Okay, got it? Now, how to write this? So the U total here is firstly by this combination, the two mass particle, then this, and then this. There is no other combination is can be possible. Only M1, M2, M2, M3, and M3, M1. Okay. So you can write it as G M1, M2 minus G M1, M2. The distance between them is R2 minus G M2, M3 divided by the distance between them is R3 minus G M3 M1 M3 M1 or M1 M3 is same. Okay, divided by the distance between them. Okay, if you have four particle, then four terms will be there. How many combination will be there? Let's say this is M1, M2, M3, and M4. So how many combination is possible? M1, M2, M2, M3, M3, M4, or M2, M4, or M1, M3. Okay, you can take each time you have to take two mass particle. Okay, so M1, M2, M2, M3, M3, M4, M4, M1, and what is left? M1, M3, M2, M4. Okay, the simple trick is that this is the four mass particle. Let's say M1, M2, M3, M4 you have. So consider first particle. Make the combination from this. So M1, M2, M1, M4, M3, M1. Now take the another particle and see what combination is left. So M2, M2, M3 is left, M2, M4 is left. Okay. Then M3, M3, M4 is only one. Okay, because M3 and M1 is already covered. Yeah. Okay. So the formula for that, if we have n particle in the system, So the total pair, the total pair of potential energy will be what? Capital N into n minus 1 divided by 2. So these are the possible combination. Put n is equals to 4. 4 into 3 divided by 2. 2 2 ja 4, 2 3 ja 6. 6 combination you will have. And you can say it is for M1, M2, M1, M3, M2, M3, M2, M4, and M3, M4, or one is left, M1, M4. Okay. So 1, 2, 3, 4, 5, 6. So 6 combination you will have. Okay. Note it down. It is important. Now the orbital velocity we are talking about. So have you got the concept of potential energy? Any kind of doubt you guys have? You can ask in the chat box. Okay. So JNV Haveli Shayad and Priyanka. Have you got this concept? Any kind of doubt you have? Please be response ना, so that I can consider कि हाँ आपको आ गया समझ में या नहीं आया. ठीक है. You can also give the thumbs up and all the reaction part. ठीक है. So have you got this? The previously taught concept, the concept of potential energy. Okay. Please be responsive. It is for your good, na? If you respond, that it will also uh, enhance your knowledge ki haan, what part I have considered, what part I have understood well, okay? What kind of doubt I can have. So it is for your good. Okay, whatever. Now the orbital velocity we are going to cover. Orbital velocity is the minimum velocity that is required for any kind of particle to rotate about the another particles. Okay. This is the minimum velocity that is required for a particle to rotate about another mass particle. Okay, JNV Avail. Thank you for the response here. Okay. So orbital velocity is the velocity at which the body revolves around the other body. Okay. Object that travels in the uniform circular motion around the earth are called to be in orbit. So these circular tracks are called the orbits, and the particle which is moving on that tracks are called the satellite, the natural or artificial. Okay. You can also say that the velocity with which they are moving is termed as the orbital velocity. Okay. So this velocity of this orbit is dependent on the distance between the object and the center of the earth. Okay. Now from expression you will get it. Now we have to derive the expression for the orbital velocity. Now we will consider that this is our earth and a particle is at a distance r from the center of this, and this particle is present here, and let's say the mass of the particle is small m. Mass of the earth is m. Okay. And let's say this particle is rotating about the Earth in a circular orbit. ठीक है? With a velocity v. Now we can say that to revolve about any heavy particle, we must need a force. The Earth is directly applying a force towards it, which is the gravitational force. Okay. So F gravitational here is equals to GMEM over R square. ठीक है? Got it? Now, what you can say, this is orbiting in a circular track. So there must be a centripetal force which is acting towards the center of the Earth. And this centripetal force is to be sufficient enough so that the particle remain in this orbit, does not leave this orbit. So here we can say that here this gravitational force between Earth and the point mass is acting as a centripetal force. Okay, so you can say that this Fc centripetal is equals to F gravitational. Okay, so Fc, we know what is the force of centripetal force. It is mv square upon r, and r here is the radius of the circle, which is small r, is equals to Fg. Fg here is G me small m divided by r square. ठीक है? Now this r cancel this r, this m cancel this m. So from here you can say that v is equals to root g me divided by r. Now if the point mass is present on the surface of Earth, so what you can say that this r will become re, the radius of Earth, because the particle is now on the Earth's surface. So from the center the distance is re. Okay, put that, so this v will become gme divided by re, and this is nothing but the orbital velocity of any object from the surface of Earth. This is the orbital velocity. Which is nearly equals to 7.92 kilometer per second. It is kilometer per second, not per hour. So what happens is, we have two stages of rocket. Okay. First stage is required to keep that satellite attain the required height. So वो मिसाइल क्या करेगी, उस सैटेलाइट को एक रिक्वायर्ड हाइट तक लेके जाएगी, ठीक है, फ्रॉम द फर्स्ट स्टेज कंबशन. And when the first stage combustion is acquired, the required height, the required altitude is being acquired. You have already seen when we launch any satellite, the rocket that will move up, it will tending towards the horizontal. It is not constantly moving up ahead with a vertical. No, it is constantly inclining itself. And because of that, when it attain a height, from the screen you will see this is the earth, this is the height attained by that rocket, and it align itself in the horizontal direction. Okay, it align itself the horizontal direction. Then the second stage will come into contact. Then the second stage propulsion happen, and it gives the satellite which is present here, satellite, the proper velocity of 7.92 kilometer per second, so that it orbit along the circular orbit around the earth. Okay, so that is how the satellite is launched. Got it? This is the orbital velocity. Now the escape velocity. What is the escape velocity? So escape means leave, बच जाना, निकल जाना, बाहर चले जाना. So same scenario is here. The escape velocity is nothing but, escape velocity is nothing but, in this GIF you will see this satellite is revolving around the earth in a circular orbit, and it is not leaving the earth because it is orbiting around the earth with a velocity which is orbital velocity. Okay. Now the escape speed or escape velocity, you can say, it is the velocity, the minimum velocity that is required to send any kind of object to leave the earth gravitational field. Okay. And not only the earth, for each and every planet there is a gravity exists. So escape velocity is that minimum speed that is required to escape from the gravitational field of that planet, so that you will never come back. Because if the speed is less than the escape speed, the earth or that particular planet will attract it toward itself. But for the escape speed, the earth gravitational field or any other planet gravitational field is not sufficient enough to hold that particle into its field. So the escape speed is the minimum speed with which a mass should be projected from the earth surface in order to escape earth gravitational field. It is also known as the escape velocity, that the minimum speed that is required for an object to free itself from the gravitational field of any other planet or any other massive object. Okay? The one thing that to be note here, not the escape speed is independent of the direction, which means if you shoot that object from any kind of angle, any different angle, with the escape velocity, it will definitely leave from the earth surface. Okay. So it is independent of the direction of the projectile. Okay. Angle of projection. You can also say it the angle of projection. The main concept that is to be tell here that initially, if a particle is present on Earth, we would consider the example of Earth. The particle is here firstly. Then we will give it a escape velocity and it leaves the Earth gravitational field of attraction. Let's say the particle is here. Okay? Which means at that time, the kinetic energy and the potential energy of the particle should be zero because it has acquired that velocity, leaves the Earth surface. Leaving the Earth surface means it is decreasing its potential energy initially because initially this particle that is Earth has a mass me. This point mass has a particle small m, and this is a system, and this is present at a distance re. So there must be a gravitational potential energy. Okay. So at the time when you give it a escape velocity, the final energy of the particle will become zero. The both energy, the kinetic energy and the potential energy. So you can apply here the law of conservation of energy. Okay, got it. So initially you can say that kinetic energy initial, kinetic energy final, sorry, potential energy initial, kinetic energy final plus potential energy final. So if you give it the initial speed as the escape speed, which is 1 by 2, initially you have shoot it with a velocity which is escape velocity. So 1 by 2 mv square minus, because the formula for gravitational potential energy is minus g m1 m2 by r. So it is minus g MEM divided by RE is equals to the final kinetic energy when it leaves the gravitational field is zero because it is now not moving in the interstellar. It has leaves the Earth surface. It is in a field of no gravity. Okay. So it remains stationary there. Zero plus final potential energy will also zero because there is no gravitational field around this object now. It is free from the gravitational field. And if it is not in a gravitational field, how the gravitational potential energy can exist? So both the term will be zero. So from that you can equate it like 1 by 2. Just a second. 1 by 2 mve square is equals to gmem over re. You can cancel this m. So ve, the escape velocity is 2gm E divided by R. This is the expression for escape velocity or escape speed. So VE is equals to root 2 times, this is root 2 times V orbital. This GME upon RE will become the orbital velocity. The second relation you will have like this. Okay. Approximately the value of this escape speed is approximately 11.2 kilometer per second. Okay. This escape speed is also termed as the second cosmic speed. And this VO orbital velocity is called as the first cosmic speed. Okay. But what happens if you provide more than the gravitational field? Sorry, more than the escape speed. If you projected a particle with a speed which is more than the gravitational field, more than the escape speed. So when v is greater than ve, then at final position, at final position, the velocity of the particle is not zero. And when the velocity finally is not zero, which means there is a kinetic energy in the system, in the particle. Okay? So it will move with a constant speed in the interstellar. And that speed is termed as the interstellar speed or the third cosmic speed. Third cosmic speed. Okay? So this is all about the velocity. If you have any kind of doubt, you can ask. Now, we will talk about the trajectory of a body thrown from some height. So first case, this will take only hardly take 1 to 2 minutes. So case first में, if v is equals to v naught, sorry, v naught is the orbital velocity, and orbital velocity is root gme over re plus h, which means from a height h, from the surface of Earth, you have projected a particle. So we have seen it. If you give the orbital speed, it will have a circulatory motion. It will go around and round about the center of Earth. So the path will be circular with the center of Earth as the center of rotation. Okay. Now, if in the case when the velocity imparted, this is the velocity which is given to this point object, this is Earth. Okay. So this is height h. So if the velocity is given is less than the escape velocity and greater than the orbital velocity, then what will happen? In this case also, because the velocity is not equal to escape, so this particle will not escape from the gravitational field of Earth, but the path of trajectory will change and it will have as a elliptical orbit. Elliptical orbit. Okay? With launch site at the apogee of it. Okay? This is the perihelion position, then this is the aphelion position. The point of projection will be the perigee of the ellipse. This point is termed as the perigee, which is the minimum at the minimum level of the surface of Earth. Okay? In this case, when the velocity is equals to the escape velocity, v is equals to v escape. Here, the velocity is v, which is equals to v, and this is our Earth, and this is height h. So what will be? The particle will leave the Earth. Leave the Earth. But according to which path? This path should be the parabola. And it will never come back on the Earth. Okay. Last but not the least, if the velocity of projectile is greater than the escape velocity, which means v is greater than the escape velocity, so that in that case also the particle will escape from the Earth, but here the path of the projectile will be hyperbola. This is a hyperbola. Okay, this is your Earth, this is height h, and this is the velocity. Okay. So this is it from my side. If you have any kind of doubt, you can ask. Otherwise, the lecture is been over. Thank you so much for being attentive. Thank you so much. Take care yourself. Keep studying.